here. And we should be live on YouTube as well. Let me see which attendees we have. Great. So these are two participants who always show up without fail, and that's great. I was wandering around the Gather Town, and I was thinking, are these guys going to show up? And I'm so glad you did, because I thought we had a really good Q&A last night, actually. And so I'll make the same offer as I made before. If you're joining through the feed loop or through Zoom, and you would like to turn on your camera and you'd like to join the panel, just raise your hand and I'll enable that. But I'm not going to put any pressure on anyone to do that. So let me start first of all by saying thank you to Jana for showing up. She has pulled the worst time zone combo I think of anyone so far, and this is even worse than our poor people in Australia and Japan who are at the very end of the live sessions. So thank you, Jana. Really appreciate it. And even when I sent her the invite, this is not a stealth thing. I didn't just say, FYI, I'll see you in the middle of the morning. I asked, is this going to be okay? And she said, yeah, it'll be just fine. So thank you. Okay, so what I said at the very end last time was that could we have any questions? And sure enough, we got a great question, but we got a great question when there was 59 minutes on the clock. And so I said to Jana, I'll tell you the question, but don't answer it, and we'll come back and we will address it at the end. And so the question was this. The question was, what should young PhD students look into? And by look into, I think the question is implying sort of what sort of research questions are interesting ones. And so it's a tough question.
It's a super tough question. It didn't let me sleep, and I still did not come up with a good answer. I think that I mean, like everywhere, it's really important to collaborate, and in formal methods in robotics, I think that holds twice. So if you are in formal methods and you are profiling your PhD in formal methods, I think it's really important to talk to people who understand the robotics problems and then listen to them very carefully and try to understand what's important to them so that you can see where you can apply what you do. And then don't get disappointed if it happens that what you need to apply is simpler than what you have developed, because I think that the tools in formal methods are much stronger than what is often needed to address a particular problem. And then if you are in robotics and you are playing around with the idea, I want to do some formal methods, it's equally as important to talk to formal methods people and be patient with them and try to explain them carefully what's important to you and what you appreciate. And then you know, it's two very different roles. If I were to bet on something these days, I would try to focus on the combo of formal methods and learning. I think that there is such a huge potential for those two things complementing themselves. That's what I would. That's where I would go, and I think that's where a lot of people are going these days.
Yeah, I mean, certainly it's a very active area, right? That makes sense. And I mean, it's interesting because tomorrow is the Test of Time Award, and then there's and so we're talking about a paper which is more than 10 years old, right? It was a different world at that time, right? And so of course a lot of the work they're talking about is model based, and then towards the end they say, so what are the prospects for the future, and where do models come from? And they come from data, and so can you just operate on the data? And they talk a little bit about Wissam specifically talks a little bit about techniques where you can kind of use some of the structure that we know from engineering and apply some of those methods, and that can do better than both. And so that's I think a very valuable point of view, and it's something I think perhaps similar could happen in the formal methods cases, right? You can understand some of the sort of, I'll say, the classical decompositions into pieces that and then you construct the networks out of those pieces, but then you still run stochastic gradient descent on the pieces so that the errors can kind of wash between the boundaries and so on. That seems like an idea which I think we will see over and over again. But I was really glad to hear what you said about be patient with them. I think that's a very interesting, because of course they're being patient with us, right? So yeah, that's the thing to remember. But I'd said this earlier to you, which is that one thing that I was kind of blown away by in your presentation was that not only did you find the time to spend a little bit of time doing motivation and giving us just a little bit of background, but then you had many of examples of ideas, and then you had not only examples of ideas, but you had different application domains for all of them, different robotic domains for all of them. And I said, where you've got manipulator example, an HRI example, and a self-driving vehicle example, and all of these. And you said to me, well, that's because I have all these great collaborators. And so actually, when I went away, I thought I should ask you about how you manage collaboration. And you've kind of already given a bit of an answer there, specifically with these formal methods people, but you have a very active set of collaborators, it seems. And so do you have any advice on that?
Not really. I mean, I just like chatting to people, and I just enjoy the robotics as a broad field. It's so fascinating. So whenever I see something, I just ask myself, is there something that we can help with? And then I ask those people, is there something that we can help with? It's usually this way that we from formal methods are sort of like desperately fishing for the applications. So it's more of, I think it's more of me starting like fishing for collaborations elsewhere, but I wish that it would turn around a little bit and people would just come to us and say like, hey, I have a problem and I would appreciate some rigorousness and some guarantees in there. Can you help? That would be fantastic. But I think it's a little bit of, maybe even personality thing. I just enjoy talking to people, so that's what I do.
Yeah.
No particular advice.
Be a nice person to talk to, and then you'll find that you'll have people to talk to, which is not perhaps bad advice. But one question, so one thing that of course happens is that there's this process where you have an interesting idea, or you're looking for a problem, and you bump into someone and you have a conversation about something, and then ... skip forward 2 years, and there's a paper that appears, right? And the paper has this in a great motivation, and everything makes sense in the paper, and it dovetails all together, and there's often a huge gap between what you first started, what your thought was about what this collaboration was going to be, and what you kind of ended with at the end. And at least that's been my experience, and so I'm not sure if that's true with you. Maybe that's not. Maybe there's some other people who can be very task directed. But so you said be patient with them, but you kind of also need to be patient with finding the problem sometimes, I think, right?
Definitely. I think it's usually it's two-way street. It's like with that STL and exploration, I really, really wanted to put STL and exploration, and we were finding a way. And then in the end, we ended up putting just such a tiny little fragment of STL because that's what made sense. So yeah, it's a little bit of compromises there as well on both ends, I think.
Well, so I kind of want you to repeat what you said a little before, because I said the amazing thing about that work was at the end you showed. I said it this way. I said it sort of came out of nowhere at the end, where you said, "Oh, by the way, if you do this, it improves the method. It's faster and it's more complete." And then you sort of you made a comment about this is what roboticists are looking for, right?
Yeah. I think it's just that for formal methods people, I think it's important that things are very neat and theoretically solid, and sometimes we are even looking for something that's challenging or difficult to tackle or elegant or something like that. While in robotics, when I started publishing in robotics, there were a lot of rejections coming because we did not have good enough applications, and we were not able to feature our things as useful. So this is really interesting that at one point we realized that we really need to kind of prove the point and find where we help. And we started not only designing the solutions that are theoretically pretty, but also that kind of help on a real problem there.
I have an economist friend who uses the phrase, he says that every community has a taste function, and you have to learn the taste function. And when you figure out the taste function, now you can finally engage with the community, because you can motivate, you can write an introduction, which poses a problem where there's someone in the community can read that and say, yeah, actually, I do want to know how you do that. And and I actually think it's one of the great things about being a roboticist. I'm a computer scientist, but I'm a roboticist, and is that we have this sort of breadth of everything which falls under our umbrella. And you can kind of, if you were to somehow plot the vector space that describe the features of the papers, the extremal points, even in the papers that are in this RSS this year, they're very far apart. So which I think is great, because there's always things to work on. You can kind of be curious about, and that probably speaks to the fact that we're not short of problems, right? We've got plenty of problems. The question is, there's often a long way to go to present that problem to someone who has a tool. So
that's true. That's very true. Yeah.
So I want to. So there's a quotation from Edgar Dijkstra, who I'm going to paraphrase it. I don't have it written down here, but he says, tools have sort of a very pernicious way of influencing our thinking. And so what happens is so that's sort of what he says. And it's, my interpretation of that is he's saying, in the beginning, you have a way of viewing the world, and you have a tool, and you gradually try to make sense of this, and then you just start to see the world through the tool. And this is something which has kind of always surprised me a little bit about formal methods, right? So there's this great lecture that Robin Milner gave when he opened called Is Computing an Empirical Science or Experimental Science? And he of course, famous theoretical computer scientist, right? And he has a little commentary in there, which is that, okay, this area is called formal methods, and I kind of wish it weren't called formal methods, because that emphasizes the method rather than maybe the other aspects like elegance and precision and articulating problems. And so I'm just sort of curious about your thoughts there, because and I don't mean that as an insult, because he's saying like, oh, he was someone who was really in that community, of course, with CCS and all the notions of biosimulation and those things. So is that not a risk that you feel potentially people who kind of come from the formal methods point of view have, or as you said it another way, they've got something very complicated and all you need is a small fragment? So they say, dig harder, find me something where we can really use all this stuff. Do you think that's a problem?
I don't think it's a problem. It's just I think it's just a lack of communication between the communities so far, because I think that what is often appreciated in formal methods is this generality and universality and understanding the problem as a whole. Whereas then from robotics, a lot of things are engineering, right? There is a lot of engineering behind what then comes out, and then we are looking for domain specific things and things that fit that problem, and then this is the fight: is the generality versus domain specificity. And we would love to take the formal methods and love to take the strength of it and then put it on a particular robotic system. It's never gonna work. It's never gonna scale. So we have to cut a lot around to make it work, to make it scale. And then that happens that there are formal methods. It's not a single formal method. There is no universal solution, but still you get a little bit of that universality. You still get, however I change my environment, however I change my specification with that particular modeling formalism, with that particular specification formalism, I will be able to work. So I think that this is a little bit of the fight in the thinking and the viewpoints on what's important. Is it that we design solutions and we prove that things are undecidable and we prove that they're X time complete, or is it that we actually make them work? And if you want to make them work, you have to cut. That's that.
Yeah, you know, one of the people you mentioned in your talk was Hadass, and I remember once presenting an RSS poster in Michigan to Hadass, and one of the results was, oh, this problem is, you know, NP complete, and she said, and so you've still got to solve it. You know, this is the point of view which I thought, yeah, no, that's exactly right. All the interesting problems are at least as hard as that, but your robot's still got to act, so you better work around it. Yeah. Which I thought was, which is in her charming, but her charming directness. That's her one of the things that's so lovable about her. So I wanted to ask you, because actually you said something which is now, there was something I was speculating about. So you were saying that, so the intro goes something like this, which I know I already said a little earlier, but you were talking about how, and you were just talking about it right now, there's this portion where there's this nicely enveloped functionality, which is dealt with a formal, let's say a formal method. And then these other parts, there's the perception and the gesture recognition and so on. And then you said, you know, toward the end of your talk, you'd like to have a little more of those, tackle some more of those components with formal methods, or bring some of the strengths of formal methods to those. So what I wasn't kind of clear about is whether your vision is that there's this portion. So let's start simple. So let's suppose you've got a very simple discrete task, and I'm going to use LTL to describe task level behavior, right? And then you say, okay, now I'm going to add in some coordination, because that's something you've done, right? Where you say, and I want to add in a little more perception or something like this. Is it that this kernel is growing to encompass more, or is it that there's sort of a formal method for the task planning and a formal method for the coordination and a formal method for the gesture recognition, and then you can somehow relate their formal claims? What's your vision for how you're going to, how is formal methods going to, how are they going to be end-to-end formal methods? That's what I want to know.
End-to-end formal methods. I think that it's sort of going to go both ways. So far, I think we have seen much more of the coming from the kernel and growing. So we start with something that is working, and then we start relaxing assumptions around it. So we start, you know, instead of assuming that we have a deterministic transition system, we start relaxing on that, and we add on the probabilities and things like that. But as formal methods were expanding, I think that they kind of settled in a couple of distinct areas, like in task planning, in motion planning, in control, and then there is something also for perception. So maybe we will get to see a little bit, like a little bigger, a couple bigger areas where things will start growing from the kernel outwards, and then I hope that they will kind of overlap at some moment. So we have seen some works on you know, integrated motion planning and control.
Sorry, my lights turn off if I don't keep moving.
Integrated motion planning and control, or integrated mission and motion planning. And then the beauty there, I think, is that you can use some sort of LTL on mission planning level, and then you realize from that you kind of come to assumptions that should hold on the motion planning level, and they can be again in some LTL or in some temporal logic. And you can, I think that the potential formal methods there is to be the language that communicates between the layers of the planning hierarchy. And I'm hoping that it will also happen onto the perception.
Well, you gave some pretty concrete examples of perception about how you might impose some constraints on, you know, you might want to apply a formal method to a network architecture and understand the network architecture, or constrain, I guess, some of the reinforcement learning activity. Yeah. Another one that you touched on there. Yeah, so I see that. That's quite interesting. When would you consider, so in this like TAMP, or this case where they're combining motion planning and task level, more than one level, I know that there's some work where they're using, SMT solvers and things like this. I consider that to be in the camp of formal methods, although it's not a logic based, but am I wrong? What's your feeling about that?
I also consider it to be in the camp of formal methods. There are even some works that use SMT in combination with temporal logics. It's kind of like SMT as an alternative to the classical automata-based solutions that scale a little bit better. So yeah.
I asked that just because there's slightly different people who in our community, slightly different people who seem to use them a little bit. And yeah, I'm one of these people who's I've been to CPS week once, so I know, a little bit about hybrid systems and some of those things. But yeah, it's not my main community, but one that I'm very interested in. Actually, I think it's a very interesting, there's something actually really nice about your talk, which showed that sort of in the beginning, these formal methods were outsiders. I don't think that's the phrase you use, but they were the new kids on the block, but they weren't clear if they were going to be contenders, And now they're not. Now they're one of the tools. They're definitely one of the tools. And so you've seen that. I mean, not only seen that, you've had a causal effect on that as part of your work, has kind of been establishing that. And so I think that that's something which is interesting to see, because it's different from, for example, the way vision has changed in 15 years or 10 years or whatever it is. That's kind of a different sort of thing where somehow it seems like the hardware architectures and the problems that were solved and the fashions changed. And I don't know that, formal methods, I never had the sense that it was, people were always saying, look, you're going to want robots where you can make guarantees. And where are those going to come from? There are not that many options. Here's a real option. Here, and so I think that's interesting. I'm going to pause because I've got lots more questions. I mean, we're probably not done here. In 8 minutes when we're finished, and a year from now, when I bump into you somewhere in the next conference, maybe the next RSS, I'll probably still be asking you questions. I probably will say, oh, you know what? I binge watched all the early last night, and your talk came up again, and I wanted to ask you about something. So I'll pause just to give someone else a chance to get a word in edgeways. Otherwise, so I'm really curious about two things. So there's two things that and I'll tell you what, and they're kind of they're diving into a little more detail, which is not great for 4 a.m. in the morning, perhaps. But I want to know a little more about assumption guarantee synthesis. I'm captivated by this idea. Yeah, and the other one that I'm kind of curious about is also where you spoke about this sort of backward reachability tree where you modified A star. So these are both kind of detailed questions. So any takers? Are you interested in talking about either of those?
Sure, we can begin. So the assumption guarantee, that's also kind of like a topic that comes from the classical theoretical computer science side that we try to embrace. Well, the idea there is that you can provide guarantees, but then you have to have assumptions always, right? If you don't assume anything, there are no guarantees whatsoever. So the idea there is, let's synthesize guarantees alongside with the assumptions that need to hold. And then you have the system, you have the assumptions, and you have the guarantees. And as long as your assumptions hold, then your guarantees hold as well.
Sorry. No. So you had
Go
this
ahead. No.
Slides about the it's safe to go when the light's green for you because it's red for them because you know their property. But only if they're not going to cross on the red, right? So that you need assumption, otherwise you've got nothing. So I thought that was great, but I don't quite know what it means to synthesize that.
Okay, so technically, the way we have been approaching it is that we have a model for our robot, but we have a model for the rest of the stuff in the environment. So I know it's probably not the very right thing to do, but let's assume that a human is a POMDP or something like that. And then that POMDP has choices, right? There is a policy. So let's say that we forbid some of the choices in the decision making. Some of the we just say this subset of policies you can take, but this subset of policies you shouldn't. And by communicating which subset of policies is okay, we are imposing the assumptions there. So it would look like this technically. And then the idea there was not only to look into assumption guarantees, but to look a little bit into which assumption set is the correct one for a human to be the most accepted. So you can tell the human never cross on the red light, but you can tell the human also never cross the road ever. And then you still have your guarantees. Yeah. But people will probably not be okay with that. So, so the questions that we are asking is, which is the least limiting set of assumptions that I can impose on the human or on any other, on the environment that will yield me some guarantees. And one thing that we are trying to do with this is not only to impose the assumptions on humans, but also on the other robots. And we are trying to use this idea for multi-robot coordination. So communicating these assumptions as sort of a part of auctioning. So that's something we are trying to do.
You're saying that, I could see there. That's very natural, because actually that gets around this, because you have this difficulty of what people are going to find plausible. But if there are other robots, then you can have them do that. Yeah, that's really, actually, I really like this, because there's a sort of spectrum where if you assume nothing, it's the Wild West and nothing's ever going to be safe. And if you say, oh no, I can make arbitrary assumptions, well, you get safety for free, because just to make everything just benign. Yeah. So the question is where is that or it's not the question, but there's many interesting questions about how you formulate this middle ground and put constraints there. And that's interesting. And it has a little bit of the flavor of this sort of minimal relaxation aspect as well, a little bit. Because you're kind of imposing constraints, and then you're understanding what happens when you tweak or modify the constraints. That's great. Thank you. I'd never seen those words, assumption, guarantee, synthesis, but I could understand exactly what you said in that slide, even though you said I don't have any time. But I thought that's fine. I've got you a little later. I can try to get an answer out of you. So that's great. We have only 2 minutes left on the clock, which I don't understand, because it feels like we've been talking for 5 minutes at most. But does anyone else want to ask a question? Oh, we've got one. Yeah, thanks, Matt. How do you think formal methods can gain more attention, especially for junior researchers?
I don't know. It's a tricky question, because
I was worried you were going to say there needs to be another Ariana disaster, and then we'll get more. So that's a throwback to the previous conversation about how Jana got involved because she saw Ariana 5. Sorry, I'll let you answer the question. But
no, I really don't know. It's not one of those areas that would be so hot and impactful. I mean, you see everyone is doing learning now. So I would say, let's try to identify what's missing, and then what are formal methods good at answering. I think we just need to do talks like this and chats like this, and try to put it out there as and it will happen eventually, that people will pick up on these things. And I think that a lot of people are missing some features of in their designs, in their solutions, and we just need to yell at them. Formal methods are here. Yeah. Just grab it. And of course, it's a little bit about that communication between communities that we have been talking about. It's such a different thinking. It's such a different style of research. They even, like in formal methods in TCS, they even order authors alphabetically, because everyone has an equal contribution. So it's a very different style. So I think that we have to work on making those communities understand each other, so that we, we get everything that is offered. And
yeah, I mean, maybe if I could be very practical, one way is we should have some junior researchers propose workshops, maybe where they invite
definitely.
people, and you know what's great about organizing a workshop is you have a lot of conversations with people, not just in the workshop, but in the organization, and hanging out with them, and so that, I mean, if my own grad student asked me, how do I get involved with this, I would say, okay, who do you want to visit? We'd find a lab and we'd try to figure out who could make happen, right? And so, I mean, I think it grows one person at a time. And we should bear in mind that there was a time in the 70s and 80s when logic was the hot thing, right? Non-monotonic reasoning, and that was the thing people were excited about. Just because no one's wearing flares and have, big sideburns now doesn't mean that isn't going to come back. That can come back. Right? I mean, neural networks when I was young were the least cool thing you could do, right? So anyway, now I've gone over a minute here, but Jana, thank you so much. It's honestly been
thank you, Dylan.
And again, thank you for the excellent talk. That was not I could see you didn't click record and run all the way through that. That was really well put together, and it's gonna live on the web. So hopefully this will be one of the things that will inspire the next generation. So thank you so much.
Thanks so much, Dylan, for having me. Thank you.
Oh, no, absolutely.
Nice.
My pleasure. And as I said, sort of congrats on the award. And I could say that because the awards committee they told me Jana's won the award. I thought, excellent. So congrats on the early career talk.
Thanks so much. Thanks.
Yeah, sure. Take care. Bye.
Take care. Bye-bye.